All right, let's finish on out on 6, talking about networking. We've got several things they want you to learn in the section. So I'm going to talk about those different areas right there. The difference between a MAC address and an IP address. And then how the IP address shows you the network and the host address. And it wants to know what class that address belongs to, so we'll look at that in just a minute. As part of the other, actually. And what subnet mask for that one they're giving as an example right there is. So you've got MAC addresses and you've got IP addresses. MAC address is a physical address. The IP address is a logical address. MAC address is assigned to the network interface card at the time of manufacture. So when the card is manufactured, and it could be a separate network interface card, or it could be integrated into your motherboard, wherever that network interface is made of put into the machine, a part of it, that it's going to be assigned a MAC address at the time of manufacture. It is a 12 hexadecimal character long address. The address tells you who the manufacturer was, and then it's a serial number for that manufacturer. The first half of the MAC address is the manufacturer ID, which is assigned to them by one of the internet agencies. And then the last half of it is assigned by the manufacturer when they make it, that they will put a unique number for the last half of it on each one. So anything that will connect to the network will have a MAC address. Okay? It's not something, basically it can't be changed. It's burned in at time of manufacture. All it does is it gives us a unique address to every interface. Okay? There is no relationship between interfaces within a network on MAC addresses. The relationship between them is purely about what manufacturer made them. So there's a code given to the manufacturers that they use. Of those codes, I don't know those codes except for one code, which made sense when I got told what the code was, and it's actually not being used now, which was Cisco was originally assigned the manufacturer code of 00000C. But long ago they ran out of numbers that were in that address. So they may be using that address again now, actually. There shouldn't be, typically, that there's always been told that you couldn't have two items ever have the same MAC address. However, that's not quite true anymore. With the tons of things that have network interfaces, that addresses can sort of run out there. So at this point in time, sometimes some of the manufacturers have gone back and are reusing old codes on new stuff. And nobody's going to be using a 300 baud modem anymore. So anything that's running at that kind of speed or whatever, they can go ahead and count as that device doesn't exist and use those addresses again. Does everybody follow on that? So effectively, we're not duplicating addresses because you can't have two of them out there the same on the network, okay? And given those constraints on it, that's not going to happen. Nobody's going to have the extreme slow stuff from the 80s still running. So they can go ahead and use addresses they used in the 80s again on it. It is burned in, so it's not something you can go in and change. However, there is an exception on that. Routers. it is possible to go into a router and change the MAC address for a router. Now, you're not going to actually change the burned-in one, but you're setting a different address for it that it uses instead of the burned-in address for the router. Now, there's a reason for that. All other devices, essentially, you can't change the MAC address. But on the router, there's a couple of instances where you do want to have the ability to change the MAC address for a router. A large organization that has a number of routers all set up, has set up all of their addressing tables and everything, and how stuff's forwarded through their network and everything, and is based on MAC addresses, etc., all built in their organization with MAC addresses used throughout the organization from router to router, etc. on it. A router dies. If they go to replace that router, they're going to have to reprogram their entire network about wherever they were using that old MAC address for the old router on the network to keep it all going, because otherwise they're all going to go, all of those other devices are going to go, don't know where that one is anymore because that MAC address doesn't exist, but you've told me that's the way to get to wherever. So you can actually go into, when they go to replace the router, they can actually go in the new router, change a setting in it to change what it appears to be the MAC address for that router. So then they can put the new router in. It looks, as far as the network's concerned, like it's the same router was sitting there, and everything keeps right on working exactly the same. Saves a whole lot of work for everybody and keeps the network smoothly working right on along. Does everybody follow on that? But you really haven't changed the actual physical MAC address. You have just changed a reference to it in there. The original burned-in one is still there. So if you wiped out what's in your configuration of that router, you'd be back to the original burned-in address. So the original address still does exist. It's just it has the ability for you to override it as part of your configuration. Second one is, and this will come into play with your home usage of the internet, that some of the providers, depending on how they've got their stuff set up, and particularly the cable ones, will do this. I know in the past Ringgold Telephone was doing with DSL also, but I don't know if they still are or not, that with the way they set it up to control what the traffic's coming across to make sure that people are paying for their service, or otherwise they're not allowed to send stuff across on the network. Just think about it, when you hook up to a cable network, you're hooking into something live there, and it's their end's got to look at the traffic and go, is this traffic that I allow playing through here, or is this not traffic I allow? And that the traffic, even if somebody's not paid, they can be throwing traffic out there onto that local part, but their key is to kill the traffic from going anywhere else. And so if somebody does hook up that's not paid, yeah, they got a connection there, but they're not getting anything because they're killing the traffic at that point. What they're doing is that they're going and taking the MAC address when they install the customer. They get the MAC address off of their machine and put it in their table. And then they go, all right, anything that comes from this MAC address is acceptable traffic. And they add it to their big table there. Well, the problem occurs is that you originally had a PC there when you had them come hook up. They hooked up your PC to their network onto their modem box there. Actually their router, but their quote modem. They recorded your PC's number into their system so that your PC works fine, that they got the MAC address from it. You decide later on that you now get a laptop to set up in the bedroom also, and that you want to hook your phone through using the wireless onto it, so you've gone and gotten yourself a wireless box that you've put there and hook up, and you go to, and now you've got a couple of devices hooked on there that are hooking to their network. Problem runs into is they don't know the MAC addresses of your other devices. So you go to do anything, it won't work. It only works from your original machine. Well, there's a couple of choices to do on that one. One is you can call them up and tell them, I've got these additional devices. They look up and see you've got a real account, and then they ask you for the MAC address and add those MAC addresses to their table. And that works pretty well most of the time. And usually the times I've had to do that for somebody, it was pretty quick and simple to do. Not anything, you didn't have to sit on call waiting forever for them to get to you or whatever on hold. That most of the places have been quick and easy to work around it, but it did mean you got to report it each time. Second one is you could just give them the number for your switch box that you have now installed, because everything's going through that box, and you can give them that MAC address, put in, and then whatever you hook up, as long as it's passing through your switch box, it'll be recognized as legitimate traffic that's been paid for and allowed on through. And so, in which case, you can actually get away with, off that little router box, that's a router switch, and it's actually doing routing and switching, that you can go into them, be it a Linksys box, a Netgear box, or whoever it is, and there's a setting in there that you can tell it to either grab the MAC address off of a PC that is attached to the box, so you don't even have to know what the MAC address is as long as you only got one PC attached to it, or you can go in and tell it what is the MAC address you want this to appear as. Well, they've already got a MAC address on you at your provider. All you got to do is put that MAC address into that router switch box there, and then everything going out appears to be coming from that original PC, even though it's really coming through that switch, but everything goes through there from the other boxes, and they have the appropriate MAC address on there, and traffic goes right on. The router switch box is smart enough to know when traffic comes into it that's got the MAC address on it, that it looks at it and goes, does this really belong to me, or does it go to that other box that I know is using the same MAC address, and sends it on to the correct one on it, and that it can sit there and handle that part for you with no problem. So the MAC address being changeable in a couple of instances is highly useful. Has everybody got that part? But basically consider the MAC address as burned in and not changeable. Now, the IP address is the logical address that relates our device to our network. And there's IP version 6 and IP version 4. Okay? And that they're looking here just at IP version 4. With IP version 4, you had 4 numbers making up the address separated by periods. Each of the numbers could range from 0 to 255. So I had 4 octets making up the address. We had a number, point, number, point, number, point, number. Each of those numbers ranging from 0 to 255. They're 1 byte long, which is why they're limited to 255. It says how big of a number can we put in binary in 1 byte. Okay, and 255 is the biggest thing you can get, because you've got 8 ones sitting there, you've got 255. Everybody follow on that? Off of this, and this is IP version 4, when they created IP version 4 back about 1980, they did it based on what they saw of the world at that time. It's almost 40 years ago now. But what they perceived of the world at that point, as far as the internet was concerned, is a whole different world than what we see the internet today is. They did not see everybody having their own PC sitting at home connected to the internet. Okay? Only a few, the government agencies were going to have computers connected to the internet. Businesses would have some computers connected to it, and there would be a few educational research people that would have a connection, but that'd be about it, and there was a limit to it. They came up with a scheme to group all of the stuff and to issue addresses. You've got classes A, B, C, D, and E. Okay? They split the addresses into groups. Class A was designed to be given to organizations that were large, and that would need a large number of addresses, and they'd be given an address that then they could assign host numbers to all of the different machines in their organization. There were only 254 networks of these. Each of the networks had somewhere around 1 million hosts. I'm going round numbers for you. Okay? And actually, I just told you wrong on that. It's not 254. It's 126 or 27, somewhere in there. Okay? Depending on how we count it on 126 or 127. Class B was for what they called middle-sized organizations. Basically, you had 16,000 networks, I believe it was, and 65,000 approximate hosts per network. I think I got the numbers correct, not reversed. Class C was for small organizations. How many networks we got? Each of them's got 254 hosts per network. Don't think we had 1 million of these, but there was a limit on many of them. Okay? They give you the number somewhere there. Okay. Class D. So this number's a guesstimate on my part because I can't remember right off. But it's a limited number. Okay? And that seems like too big of a number. It really seems like it's like 65,000 also. Class D was for multicasting. So if you were going to send messages to multiple machines at one time, and streaming movies is actually done through multicasting now, you could use that. And Class E was government and experimental. Okay? Now, if you needed more than 254 addresses, you had to get a Class B address. Otherwise, you got a Class C that gave you up to 254, which meant your network at home, where you may only have 3 or 4 devices on it, you're going to have to get on this system, you would be given 254 addresses to work with. If you were bigger than that, you went 65,000 addresses. You only needed 300 addresses. Just what? There's a huge wastage there. Another one is back up here, number 127, was assigned for loopback addresses. And we actually had like 1 million loopback addresses. basically only need one loopback address for testing and doing various purposes, working on your machines, maybe a couple of them, but no more than a couple of loopback addresses. They reserved out there a whole million addresses for that were unusable for any other purpose. Lots of wastage here. When I set up Swainsboro Tech back in 1990 onto the internet, they gave us a Class C address, which gave us 254 hosts. At that point, the only people I saw in school needing an internet connection was there were several people in the office to connect student records to the central office, person in the business office, me to be able to go out and do stuff on it, and set my computer lab up so my students could get onto the internet. So that was 20. And that was it in the whole school. Nobody else did I see having any need to get onto the internet. So 254 addresses was 20. Our comments when we got given 254 addresses was, what in the world would we ever use 254 addresses for at a school? We can walk around the building right here and probably have used up 254 just in this new campus right here. On just physical machines sitting in the room, not counting the fact we've got wireless running through here, and every time one of you connects in on wireless, it's using another IP address to do that. And so we're using bunches of them. Okay? But 1990, we didn't see any of that coming. A few years later, the whole picture changed. As the World Wide Web appeared there in 93, and then all the stuff that's sitting on the World Wide Web internet today, starting from that point on. So that by 1998, they ran out of IP addresses. Because IANA issues those addresses out. And they would issue an entire block of A, B, or C to any organization needing to connect to the internet. Does everybody follow on that? And their question would be, how big were you? And they picked one of them. But there was a huge wastage on A and B. There is one organization that still has a full Class A address. Because then when we reached into the late 90s and we ran out of IP addresses, and they're going, we don't have any addresses to give out to people to put on their machines to be able to hook up with, that then at that point IP version 6 started being developed, but it wasn't far enough along and needed some definite more work on it. And that they figured out we could use NAT, and where we could tell it, all right, we'll use private addresses within the organizations, public addresses out in the world, and we would convert going out into the real world, and we had reserved private addresses for inside. And expanded everything, and we grabbed back all of those addresses we issued to all of these organizations and said, we're not going to issue entire blocks anymore. We're just going to issue the number of addresses you need as a subblock. Except for when they issued those original addresses there in the 80s, they told organizations they had been given a permanent license to those addresses. Most organizations voluntarily gave it up and got given different addresses to work with, which worked. AT&T, I think it is, I'm pretty sure AT&T, said, we're not giving up our address. They had a low number address, and I don't remember what the number was, but it was like a single digit first position. And they said, we want to keep that address. You gave us a permanent license to it. There was a court battle over it, and AT&T won. So they still have whatever that number was issued to them. As they fought them and went, yep. Court ruled, yep. gave them a permanent license, you can't just take it away because things changed. You should have known better. So they've still got their little number that they can use for all of their stuff. Everybody else is sharing all of these groups. Okay? Now, on these numbers here, but just get the basic idea here of how those numbers jumped on that and the problems. We're still using IP version 4 today. We've actually now hit, like a year and a half ago, maybe in a year or 2 years ago, the really seems like it was February, March. Anyway, last year or the year before, we actually have run out of IP addresses again in IP version 4. Because of the continued rapid growth, even with the ways we figured out ways to game the system, that they have run out again. Now, there are still addresses out there. It's just like ANA, the company, the organization that issues them out to the high-level people to then issue them out to the individual users, has run out of addresses they can give out, but almost everybody out there still got addresses they hadn't used yet. So they're still able to continue issuing to their different ones. But there's no more addresses. So just be aware of that part. Now, let's look at what those numbers looked like, which is where they came back to asking you over here about what address class is 133.66 and what's the default network subnet mask for this other number. Class A, and we don't have to worry about class D and E on this because we're just talking about addresses assigned to specific machines, and that's just going to be A, B, and C. D is multicasting only, and that's used to be able to send out one stream of data that goes to multiple machines without sending multiple streams at one time. E, I have never seen an E address in use, as far as I know. My understanding is that intelligence agencies are using it. The CIA has some addresses in that range, and that the federal government's kept. I know the federal government kept it for military purposes, and then they do a number of military things across using Class E, and then it's also used as they're trying to figure out new ways to do some different things on the internet. So it's also possible that if I had seen an address that I couldn't tell you that I'd seen it anyway. Or that if I told you, then I'd have to shoot you. So let's just not go further with that one. Okay? But that's what Class E is used for. But I really haven't ever seen a Class E address in use, but I haven't been into some of that other type stuff, as far as I know. So Class A, addresses in that range, and this is looking at this first octet. Okay? On Class A, their numbers will always start with 1 to 126. Okay? That's going to be a Class A address. So anytime you see that first octet has between a 1 and a 126, it's a Class A address. Class B will go from 128 to 191. And actually, we'll go back and look at binary on these. You can look at it's using the first bit, and then it's using the next bit with the 0 and the last bit on it. And there's a system to this. They're not just randomly drawn here. And Class C is 192 to 223. Okay? So, that address they gave us over there on the board of what IP address is 133.166.155.189. It was 133, which tells us it's a Class B address. So we follow on that? Now, off of that, what they did was that they're doing a 0 in the first pit position here, and then they've got it, and then they uses the other 7 positions. This one's using a 1 in the first, a 0 in the second, and then the rest of the 6 bits are accounted for. And this one is using a 1, a 0, and then the other 5 bits. So there is actually a system there where those numbers came from. That they didn't, I just didn't draw those numbers out of the sky, and they didn't draw them out of the sky. They had a system to decide what was which each one is. As part of this address, the first portion of your IP address is going to be the network portion. The last portion is going to be the host portion. The network portion tells us what network is this on. Every network has a network address to it. Okay? The last portion tells us specifically which machine within this network. If it is a Class A address, the first octet is the network portion. That tells us what network is it on. And those numbers, notice, can go from 1 to 126. The rest of the address are numbers we assign within our organization as far as the host number. But you can assign whatever numbers out of those you want. Typically, you number them starting from 1, and so we start with that machine as whatever one, let's say 113, 113.0.0.1, 113.0.0.2, 113.0.0.3, and so on. Although if you're backwards like him, you might have started with 254, 253, 252. Or he's sitting there and he just likes picking random numbers. As long as he doesn't repeat the number, we're okay. So he can do that one as 113.0.0.81, 113.5.7.3, and so on. Now, the problem with this random number one is if something goes wrong with one of these machines and it's telling him what the network address is of it, he has no idea in the world which machine it is, unless he's got a complete system to how those random numbers work. He really needs a whole chart listed there of them. If he has numbered them sequentially through his organization, he finds out the number or uses a system further on them, he can look at the number and go, oh, that's the third machine in whatever room. Because it may be, since you've got 3 octets to work with, you may use this first octet here to tell us which building it's in. This one to tell us what room it is, and this one to tell us which machine within that room. Does everybody follow on that? Or you could sequentially assign them all. It's your choice to decide how you assign those numbers. My suggestion is come up with a system to it. And so then when you look at a number, you know where to go head for to deal with the problem. Instead of having to get out your masterpiece thing or pull out the phone where you got it all built in a table on the phone and look it up on there of that number, and it pops up and tells you that's the machine in room such and such in building such and such. Either way will work, and there's plenty of people who do each of those ways. And whether you number them sequentially from the top or from the bottom, doesn't make any difference. Usually you reserve a couple of the bottom numbers or the top numbers. You hold them out and use them for servers and assign them specific addresses on that. Class B.
The first two octets are the network address. It's going to start with a number between 128 and 191, but it goes on into the second octet, and so it's assigned a number to it also. And the last two are the host numbers. Class C is the first three is the network address, and the last one is the host number. And there's only 254 hosts available. All zeros on there. So a zero address is a network address, and whereas 255 are all binary ones, that's actually a broadcast address, and when something's sent to that address, it goes to all the machines on that network. And that's why I told you there's only 254 hosts available. Although I told you the numbers could be 0 to 255. 255 is reserved for broadcast. Okay? The other one is there are private addresses we reserved out of each of these ranges, which get used extensively today. Not when they were originally created. The idea was if your network was not connected to the internet, you'd use a private address, and if your network was connected to the internet, they would issue you a public address. Well, all of your networks are connected to the internet today, essentially. There's a couple of them sitting out there that really aren't onto the internet. It's far and between on it, but it does happen occasionally because you've got some private specialized network there that you don't want stuff on out there possibly being hacked. As long as you don't have it connected to the other, we don't have to worry about it. So, with Class A, any address that starts with 10 is a private address. You can't use it on the internet. However, with the way I said about where we changed there in the late 90s, in 98, 99, somewhere approximately there, when we ran out of IP addresses, we told people to start using private addresses and use NAT, Network Address Translation. You set up a server connecting you to, out there to the internet, which is a NAT server. And what it does, and it's not a big fancy machine or anything, y'all's little modem box sitting at home includes NAT serving built into it, so this doesn't require anything complicated. Okay? What it does is you then build all of your addresses in your organization using these private addresses. When it goes to go to the outside world, the NAT server looks at it when it goes to go out and says, it didn't belong inside the organization, so I got to send this out. I'm going to change the address to the public address I have and ship it on out. Now it appears to come from that router box, that NAT box. It goes out there to wherever it's going. The place out there responds, sends back, which sends to the NAT box. The NAT box gets it, looks at it, and says, okay, it belongs to us, and I didn't ask for it, but it's in my table. I know actually this came from this machine within the organization. Change the address back to that private address and send it to it. And it keeps track of all of that going on at the same time. So that all 7 of y'all, plus me, sitting in here decides we're going to send stuff out, and we're doing NAT here at the college. We all send out. NAT looks at each one of us we made our request. I asked for my web page. He asked for McDonald's web page because he wants to know what he's going to get for lunch in just a little bit. And what it's going to cost him. Does he have enough pennies on him to pay for it today? Or is he going to have to beg for a couple of pennies from you before we leave school? He asked for CNN because he wants to know what's going on about something in Washington. They asked for something else over there. He's sitting working on classwork, so he's clicked out to Blackboard. The NAT server remembers on every one of us on where we sent from our machine, keeps track of it in its NAT server there, sends it out the appropriate places, and as it comes back, it remembers which one of us asked for that from whichever place, and then changes the address back to our private address and ships it to us. And for all intents and purposes, none of us had any idea that it changed addresses, and what the world saw that came from was not where it really came from. What all of those servers out there in the world saw coming in looked like it came from our NAT server, not from the individual machines here in the school. Does everybody follow on that? And likewise, when it came back, they looked at it and said, okay, I know which machine, and if we'll change the address and forward it back to the right machine. Class B, the private addresses there are 172.16 through 172.31. Okay? That one's the confusing one, because they set a little range of addresses on it. Class C is 192.168. Dot something, dot something. Okay? Now, think about when y'all have seen things mentioning IP addresses before. When they give you examples where you're reading on something or whatever. What are the numbers you saw? They usually looked like they were 10 or 172 or 192. If y'all get on and look on these machines to see what the address is assigned to each of these machines, don't remember on this campus right off, but some of ours were using 172 and some of the campuses were using 10 to do it on there. 10's the easier one to do because we've got 3 octets to play with to better describe it out. A lot of places are using the 192. Think of these private addresses as being similar to what is the phone number that they always use in movies and TV shows and in songs and stuff that's not really real exchanges for phone numbers.
555.
555. This is a similar type thing. It doesn't, these numbers really won't work really out there on the internet, but they'll work when they're converted. If you try to just take one of these numbers and put it in your box and connect straight to the internet, it won't work because it says that's not a recognizable number. But it will work in our private networks and convert back and forth. Y'all follow on that? And so in your examples and books and everything, they should be using these numbers. Now, for purposes like test questions of what does it belong to or whatever, yep, they're going to give you real ones. And who knows who in the world that address really belongs to. We could type in that 233 point whatever it was, or 133 whatever it was, and we may pop up with a web page for whatever. Maybe a web page we want to see, or maybe a web page that gets us in trouble for having pulled up. Because you may have just found your child porn web page that you didn't want anybody to be going anywhere near to. You never know when you just do numbers. That's going to have subnet mask assigned to it. Subnet mask just says which portion of it is the network, which portion is the host. For y'all's purposes in this class, we're going to take the Cisco class, the first Cisco class, which most of you got to take as your networking introduction class. You get more details on it. This one, the subnet mask, is actually 255.0.0.0. That matches back to here, 255 for the network portion, the zeros for the host portion. This one is 255.255.0.0, and this one's 255.0. Now, those can be broken down to much more numbers to it when you get into subnet. which you'll actually get introduced to in that other class, but that's not in here. Just be aware that its subnet masks are not just zeros and 255s. But pretty much for your purpose in here, that's all you need to know on. But be aware there can be other numbers. When I got my MCSE, which is Microsoft Certified System Engineer, which is Microsoft's top certification, this was all I understood about subnet masks. And I thought that was it, because Microsoft didn't teach more on it. When I took my first Cisco class and started into it, and they got hit subnetting, and they said these numbers could be anywhere from 0 to 255, each one of those numbers. It confused me for a bit. But there's a system to how you do it, and that you can actually take out of the host area, you can subnet into smaller subnets within your network. And so you get other numbers, but just be aware that can happen. All right. When you move machines network to network, from one location to another, the IP address will change. So it tells it what network are you sitting on. The MAC address never changes. So everybody follow on that? The IP address will tell us which network are we actually on. So knowing this IP address will point us to a network that we're a part of. The MAC address just tells us that in a specific device sitting somewhere out in the world where we know nothing about it in relation to others, other than who built it. And you can actually look up MAC addresses on the FCC website, and it will tell you who the manufacturer is. It's just looking back in that big master table. Questions on that? All right, well, let me flip some slides. And the way these monitors are working, I'm having to use this monitor to look from, because it won't display on both monitors for me. Now I've got to find cursor again. No idea where it's going. There it is. Because it's got it set up on 3 monitors temporarily, since we're getting ready to hook up those monitors back there. And that's got everything confused on duplicating screens and extending screens. All right, I've talked about addressing facts. TCP/IP is going to be the protocol you're going to use quite often, but it could be using UDP also to send stuff across. TCP is going to be connection oriented, which says that when stuff's sent using TCP, it's going to make sure it gets to the other end. UDP actually is how web pages actually will work a lot and stuff. It says we send it and assume it got received by the other end. We really don't know if the receiver received it or not. So you'll see TCP and UDP both used. IP configuration. Problem within the room in here is we really can't go in and look at the stuff on it because they limit it so tightly on what y'all can get in and see. That they go through, and so they show us a little on that of how to configure these, but you can configure your IP addresses in machines. Normally today, you're not going to assign, except for on servers and printers, you're not going to assign it a fixed IP address. You're going to let it automatically assign it. And it's going to use DHCP normally to do that, and that it will go and get an address to assign to the machine.
instead of you assigning an address to it. So you'll do it dynamically normally, which is, on the screen here. So you could assign a static address. If it's a machine, you have to always know what the address is. You got to use a static address. The servers have got to have static addresses because everybody's got to be able to know what the IP address is of that server to be able to access that server. Likewise, printers, network printers have got to have a static address because we got to know what the address of that machine is to be able to send stuff to it to print. If it was a dynamic address that's assigned to the printer, it'd keep changing and we'd never know what was the right address for it. So you do have an IP address you assign on there, and that every machine within your network has to have a separate IP address for it. It says here, do not use the first or last host address on a subnet address range. The first one is actually the network address, which is 0. And the last one is 255, which is a broadcast number, and that when you send something to the network address with 255 in the host portion, you're saying send it to everybody on that network. Subnet mask, I already mentioned that one to you. Everything on your subnet is going to use the same subnet mask. The default gateway is when you send something out and the network looks at it and says, it doesn't belong on to anybody on our network, what does it do with it? The default gateway says, send it that direction if you don't know where the device is. So all it's saying is, if we don't know where the device is we're trying to send to, use the default gateway as the way to get towards there. It's just the way out of your network. That's going to be your router IP address. Okay? And it just says, if we don't know where this is, send it to there, and then it will send it to its default until finally one of the devices says, I know where that is, and gets it to the correct machine. Because all the machines don't have to know about every other machine in the world out there. And then the host name is just the name we assign to this device. I just mentioned DNS is where you use your domain names, which is what you normally use to go find stuff on the internet. You type in dwightwatt.com and it finds my web page. Well, there's an IP address actually assigned to my web page out there. And what DNS does is that when you type in a domain name, it looks it up in your domain name table and says, do I know about this domain name? If it does, it knows what the IP address is for it, and then it proceeds to use that IP address. Because the internet's not going to really use domain names for sending stuff all over. They're going to use IP addresses. If it doesn't know in that table there on the machine, it broadcasts out that domain name. Does anybody know about it? And it's going to look, and if not, they'll get no responses back. But one of them is you've got several root levels of domain names. And if any of you have ever registered a domain name, when you bought the domain name, they told you it would take up to 48 hours before it may be usable out there. The reason is they write it into the root level table. The root level table is not usually accessed real often. It keeps most of the stuff that most commonly used down to your PC. It remembers where has it gone before. Well, then you got to use that new name. It's not in that table, so then it has to broadcast again to the next level. Not there, so then it has to broadcast to the next level, and there's about 5 levels that will go through. And then it will find it. And then it knows what the IP address is, and everywhere further on down now remembers that address again. questions? IP version 6. Oops. Remember, I kept telling you that's run out of number of addresses. IP version 6 has been around since about 1998. There was an IP version 4 they'd started on in the early 90s, and it wasn't going to expand the addresses and everything. It was going to add some capabilities and stuff. When suddenly the internet took off, boomed, and we went running out of addresses. They threw IP version 5 ideas out the window and started again with IP version 6. So there has been no IP version 5. IP version 6 is what we're implementing now. And that you've got most machines out there running off both both version 4 and version 6 now. IP version 6 has addresses that are 32 hexadecimal characters long. It splits them to 8 quartets. It says quartets there, but those should be, it's not quartets. Hextets. Should be hextets. I've never seen it mentioned as quartets before. Anywhere else you read, they're going to talk about hextets. Those were octets, remember. These should be hextets. It's in hexadecimal numbers. Somewhere they got quartets from, and I don't know where in the world they got that one from. I've never seen quartets mentioned anywhere else. Okay? Each of the hextets is separated by colons. So it's groups of 4 hexadecimal numbers. Okay? And they can range from 0 through FFFF. So hexadecimal numbers are 0 through 9 and A through F. You can allow for, I think it's 300 quadrillion addresses, I believe it is, that you get with IP version 6. I think it's quadrillion. It's 30 positions, 30 zeros stretched out on the number, okay? It's huge. Theoretically, they claim that we can assign an IP address to every grain of sand in the world, okay? We're rapidly headed for that type of address usage anyway. Should last us a long time into the future. It still is going to split with a network portion and a host portion, but you really don't have to worry about some of that on it so much on IP version 6. It will automatically assign addresses using your MAC address as part of it and coming off of it. And so it uses a whole new approach to it. It does let you drop leading zeros off and stuff, so there's shortcuts to reducing it down on but the big part is there's way more addresses than what we can perceive at all using today. Now, keep in mind, in 1980, when they did IP version 4, they thought they had come up with a scheme that would last forever. They had no idea we would have so much stuff all connecting to the internet, much less the stuff we're starting to connect now with the Internet of Things. Because after all, every light bulb in the room can have a sensor on it that connects back to the internet and has to have an IP address. The sprinkler out in your yard can be sitting connected to the internet with an IP address, so that it will know that it poured down rain last night and there's no reason for the sprinkler to come on today. And wastewater watering your yard when it's sitting under water still from the rainstorm last night. Okay? Your car music, your phone, you've got IP addresses sitting on it. That there's
And who knows what all is going to end up with IP addresses sitting on it within the next couple of years as the Internet of Things or Internet of Everything proceeds to take off even bigger. Okay? Right now, everything says IP version 6 is going to work forever. I'm going to tell you that no, it's not going to. It might not be in our lifetime that it runs out, but it's going to run out at some point. Probably going to run out way before we are thinking it's going to run out. Because no matter how well we've expected on it, there's things we never even thought about. Let's think back to 1980. PCs were just starting to appear, and the idea that everyone would connect together and have web pages all connecting and everything else was purely science fiction, if any thought of it. Okay? And that was way, way, way off into the future. And not something, and even with what we were looking at in 1998 as IP version 6 started being developed, things y'all are doing on the internet today, nobody had conception of at that point. That you were going to be carrying around a pocket computer on you, i.e. phone, and that you'd be watching movies, etc., playing games, all on there, and needing multiple IP addresses hooked to your hip right there, that was way on off, and that's not that far off from y'all, because that is in lifetime range for all of y'all in here. Okay? So where we're going to be in a few more years, who knows? Okay? So IP version 6 is the way it's all moving towards, but IP version 4 I suspect will be around for another 10 to 20 years. A lot of things do work both now. There are things that are still on IP version 4 and things that'll take a little while before they switch them. Most of your providers provide both you with an IP version 4 and 6 address. As of a couple of years ago, the federal government made sure all of their equipment works on IP version 6. So that they are completely integrated. The expectation is we're going to move into an IP version 6 world completely within the next couple of years. But like I say, IP version 4 is still going to be around for a long time because of how it works out there. And it will work, and it does work interchangeably between the two of them. But they will work together. But IP version 6 gives us a lot more capabilities than 4 did. So we want to get to 6. IP version 6 is also simple on subnetting. Because of all the addresses and the way they built the system, they have built where you can have thousands of subnets without having to subdivide stuff up, that they've already got 4 digits reserved for you just for subnetting, and you don't have to go and split things and do all of the tricky calculations that you have to do in IP version 4 to subnet networks. It makes it a whole lot easier there. Wireless is out there too. Most of you got some experience with that one. You do have SSIDs out there. What's the SSID? Anyone know?
SSID.
The SSID. When you go to connect to a wireless network, that name that you see pop up that says GNTC guest, that is the SSID for that network. It's the identifier on it. You don't have to put one out there for it, in which case it's basically hidden from people, but it's not really hidden. It just doesn't have an SSID on it, so then they don't know who it belongs to. Usually you put something on there that identifies who it belongs to. So then that tells people they should be able to get on that one, or they shouldn't be getting on that one. Okay? You can set WPA and WEP and WPA2 as encryption methods on there. You really want to use WPA, which actually encrypts. WEP is actually not encrypting, but is just sending it more securely across. Encrypts your passwords, but it doesn't encrypt the rest. WPA actually encrypts your communications between them. You'll notice when you're connected to the school network, they're not using WPA. Why do some of you know that we're not using WPA for the school network? It shows on your phone saying it's a risky network because it's not been encrypted, so whatever he types in his phone and sends, I can sit there and pick up his signal going across and steal everything he just sent across. So if he used his credit card number, I can in turn hand it to him and go, here, you can use this credit card number and go buy some stuff at lunch. That wasn't a good move for our part, was it? But that's where you do want to be doing your shopping across encrypted connections. So that then when he buys that stuff, I don't see his credit card number. So I can't sell it to him. Speed of them has gone up in terms of time. It's asked you there about which ones are backwards compatible with 802.11g. There is 802.11a, b, G, N, AC, and AD. And there was a Z in process, but I don't think Z ever got there. G will be backward compatible with both B, will backward compatible with B for you. A stayed independent on it. It works at a different bandwidth. Actually, AC works off on that different bandwidth too, but AC can work on two different bandwidths. I'm using AC now for mine at home. And then I've got two different wireless signals I send out, one at 5 megahertz and one at 2.4 megahertz. 5 megahertz one's faster, but it requires you have to have an AC adapter in your machine connected to that one, whereas the other one works at 2.4 and G will connect to it and work with it. But WPA will give you the encryption across there too. So you really do want to. WEP just gave you where it required a log on to it, but it didn't do any encryption in it. So you really want to use WPA or WPA2 or WPA personal now to be able to get it where it actually encrypts your signal. All right, any questions on all of that? That is the time period for the day. We've used the hour and 20 minutes. And that should have us pretty well covered on the networking. Next week, no class. Then that Monday when y'all come back, you will take the test on chapter 5 and 6 in class that Monday morning. Okay? And we will do it here in class. Any questions on that? And then we'll dive on into the next chapters after that. So keep up with your work at Test Out. I transferred a few of y'all's grades a few weeks ago, but I haven't had a chance to do more. The Cisco classes, two of the 3 classes I've got of Cisco, I actually transferred most of their grades yesterday. One of the class, the online Cisco class, I actually transferred all of their grades. The in-person one, I've got part of theirs done, and then my advanced Cisco class, I still have to transfer their grades, and then I'll get back to transferring y'all's grades from Test Out to Blackboard also. And hope to get a little bit of that done next week, but I'm intending to get away for a few days for myself next week also, and not work the whole week. Now, I agreed between the conference at the beginning of the month, although I got a good bit done while I was doing the conference, but then getting sick for that whole week thereafter that has knocked me further on back where I did not expect to lose that territory on there. So hopefully we'll get it all caught
I will see you a week from Monday, except for those that I see this afternoon, just a little bit in the program design class.